Hello. Um, our next topic is graph transformation. So, what is graph transformation? A graph can be transformed from one form to another in four different ways. First one is vertical scaling. So, what is the vertical scaling? It means that graph is enlarged uh, vertically through some factor k. Reflection is basically flip of the function. Horizontal shift in this uh, transformation, the graph is shifted horizontally either on the left side or right side. Vertical shift in this type of the transformation, graph is shifted upwards or downwards. Now we will discuss each of them individually. So what is the first one? This first one is vertical scaling. So what is now vertical scaling? If k is greater than 0, then k is greater than 0, then graph of g of x can be obtained by vertically stretching the graph of f by a factor k. This is the mathematical form of its discussion. K is some positive real number and f of x is some function. So if k is multiplied with this f of x, then new function generated g of x, this will be scaled up by a factor k. Now, scaled, or you can also call it stretch. We have an example for this. This f of x is a function, and if we multiply this function by 3, we get a new function. Uh, this was the function f of x in the blue color. If we multiply this by 3, so new function will become this g of x is equal to 3 cos x, and its graph is in the purple color. You can see in the graph. So you can see that this function is scaled up by amount this by 3. It means that if this is 1 and this is 3, so this is 3. This was 1. So if we multiply a function by a positive number, then this function can be scaled up. Next is the reflection. Now, what is reflection? The graph of g of x can be obtained by reflecting the graph of f of x about x-axis. So to reflect or flip any function, we multiply this function by the negative sign, and we get new function, this g of x. Suppose this is a function f of x is equal to mod of x or absolute value of x. This is reflected to get g of x is equal to negative mod of x. So if you see, this is the graph in the blue color. This is the graph of f of x. Since this one, we have multiplied this with the negative sign. So if you make the graph of g of x, you will get this graph, g of x. Now you can see that this function g of x is inverted, or you can also say that this is reflected or flipped. You can name it anything which you want. So here clearly you can see that this function f of x is flipped if we multiply this function with the negative sign. And now this is the function of the a graph of the g of x. Next is the horizontal shift. So what is horizontal shift now? You can see that uh, the graph of g of x is obtained horizontally, shifting the graph of f of x to the right if c is greater than 0, and to the left if c is less than 0 by a distance of unit c. So this is an example of this function. F of x is equal to sine x in blue color. Uh, this is the graph of function f of x is equal to sine x in the blue. And if we subtract 1 from this x, from this sine x, from this x, if you subtract 1, the new function g of x, its graph is shown in the black color. So this graph is shifted to the right. Look at this point. This was the 0 of this graph. Now this 0 is shifted to the right. Since we have subtracted 1 and 1 is a positive number, if we subtract 1, as you can see from the definition, that graph shifts graph, shifting the graph of f of x to the right. When any graph will be shifted to the right, if this c is positive. So this, instead of this c, I have used here 1. So this graph is shifted to right side. This was the graph of f of x. This black graph is for g of x, which is equal to sine x minus 1. So if we subtract any positive number from x, this graph will be shifted to the right side. Now, if I use here -1, so now this function will be changed. New function will be h of x. So h of x is in the red color in the graph. This is h of x. So h of x, you can see that this was the 0 of f of x is equal to sine x. Now this graph is shifted to the left side. So this is the new graph h of x. So if we use positive number here in place of c, then this graph will be shifted to the right. But if we use the negative number here in place of this c, the new function's graph will be shifted to the left, like this was the case h of x. We used here -1 in place of c, then this graph is shifted to the left now. So this is the horizontal shift of the graph. Now, what is vertical shift? How this graph can be shifted vertically? The graph of the g of x can be obtained by vertically shifting the graph of f of x upward if d is positive. So vertical shift is graph can be shifted vertically but in two ways. Either graph can be shifted upwards or graph can be shifted downwards. The graph will be shifted upwards if d is greater than 0, and graph will be shifted downwards if d is less than 0. So this is the function f of x. If we add some positive number in d, then new function will be g of x. This d may be positive or also negative. If d is a positive number, then this graph will be shifted upwards. If this d is negative, then this graph g of x will be shifted downwards. So we have taken as an example of graph of f of x again here. So this is the graph of f of x is equal to cos x. This is f of x equal cos x. So if we add 2 here, since 2 is a positive number, then new function will be g of x is equal to cos x plus 2. And this is shown in the black color in the graph. This is the graph of g of x, which is equal to actually cos x plus 2. which is this graph, this g of x is obtained by adding 2 in f of x. So you can see that this was its maximum value. Now graph of this graph shows that its maximum value has shifted upwards by 2. If you add here 4, then this graph will be shifted at 5. So this 2 is the responsible for the vertical shift of the graph. Now, if we change this function and we subtract, or you can also say that we have used here now negative value of d, which is -2. Now this graph of h of x has shifted downwards. So this factor d is responsible for the vertical shift of the graph. It can shift the graph upwards if d is positive, and how much graph is being shifted upwards, it depends on d. If the value of d is negative, then graph of this function is shifted vertically downwards. Now, it is a case of double shift. So, since we know that this c, if we subtract c from x, so this c is responsible for the horizontal shift. If the value of c is positive, then this graph is shifted on the right. If this value of c is negative, this graph is shifted on the left as described recently. So now what happened? Now you can see that uh, this is the function of example of this kind of double shift. F of x is equal to x squared plus x. So now what is f of x squared plus x here? The graph in the red color is the for f of x. Now what we have done here, we have multiplied this x squared plus x by 1/2, or we can also write this 0.5. So now what will happen? So this number will will scale the function like that. So this blue graph is for the this 0.5 times x squared plus x. You can call it anything here. You can call it h of x or anything else which you want. So this is the graph of this function 0.5 times x squared plus x. Now you can see that this 0.5 is responsible to shift its graph upwards. Now, if we not shifting, this is some kind of its scaling. Now you can see that if we subtract this negative from x and here negative from x, so this 1 is actually responsible to for horizontal shift of the graph. So this graph can be shifted on the right side, like you can see that this graph is shifted from here to here on the right side up to there. So now this +4 is responsible for the vertical shift of the graph. This 4 has shifted the function in this direction vertically upward. This negative x has moved this graph from here to here, and this +4 has moved the graph from here to here in this position. So you can assume this example for the double shift of the function. I'm hopeful that you have understand this. Thank you.